Hello, let's continue our Sudoku adventure with Flotsam by ChinStrap. So this continues our celebration of hitting adventure number 1000. And so each of the puzzles during this celebration are inspired by a previous Sudoku adventure puzzle. So here ChinStrap was inspired by puzzle number 749, Seaweed by Matt Tressel. So, ChinStrap says, I loved the initial logic and beauty of the grid and tried to preserve those both as much as possible while remixing everything else around it. All right, let's go over the rules. The rules are going to take a little bit to go over. I apologize, but here we go. So we do have we have 6x6 chaos construction rules. So it's still Latin square. In every row and every column, we are placing the digits 1 to 6 exactly once each. But there's also 6 regions in the grid, each with 6 cells in them that are all, orthogonally connected. So like this could be a region, maybe this could be a region, etc. And those regions also can't repeat any digits. They have 1 to 6 exactly once each. But we don't know where the regions are. It's up to us as part of solving the puzzle to determine where our regions are. All right. So in addition to that, we do have these arrows in the grid. They are going to help us find our regions because a digit on an arrow cell counts how many cells of its region it sees, including itself. Other regions block vision. So if this was a 2, then in the direction of the arrow, including itself, we would have 2 cells in the same region, and then we would have a boundary, and then this would be starting a new region. So a 2 would mean that. A 1 would mean that the boundary was here instead. And then this would be purple region, for example. Now, if green somehow came back around like this, that would be okay. It would still be a 1. The region border blocked its vision, but there could be another green over there. All right. In addition to that, we do have equal split line here. That's this blue line. So the splits are designated by where the circles are. And so each segment of this line sums to the same amount. So if this was, say, a 6, then this could be 1, 5, 2, 4, 5, 1, for example. And I guess I should point out that it also says that digits don't repeat within a segment. So let's say we wanted to add to 4. This couldn't be 2 plus 2, because if it was 2 plus 2, that violates the repeat rule on the line. The line can repeat, just not within the same segment. All right. And then finally, we do have this German whisper line. Adjacent digits on the line have a difference of at least 3. So if this was a 2, this would have to be a 5 or a 6. The only 2 digits that are at least 3 different from 2. Something like a 3 would be 1 different. Something like a 4 would be 2 different. That's not at least 3. All right. And that's it. Those are the rules. There's a link in the description if you'd like to try the puzzle yourself. And I'm going to get started right now. All right. The first thing I want to look at is this. You know what? Actually, before I even look at that line, this cell here can only be 1, 2, or 3 because it's counting cells, and it has to stop at 3. This is counting cells as well, having to stop at 4. This could go. I mean, all of these C is 6. They're technically 1 through 5, but I don't think I want to fill 1 through 5 in them. This can't even be a 3 though. Should I put 1, 2, 4, 5? Why not? Okay. Anyway, I don't think it's same thing here, I guess. Anyway, all right. So let's take a look at this line next. So we know this is the sum. Whatever digit goes in here is the sum because it's a single cell segment. And we also know that we can't. We need a sum that has at least 2 distinct ways to sum to it. So for example, if this was a 3, 3 can only be 1 plus 2. So it would be 1, 2 here, but now this can't be a 1 or a 2. So we can't actually sum to 3 in these 2 cells. If this was a 1, it can't be a 2. If this was a 2, it can't be a 1. So what we need, and we also can't repeat digits. So a 4 could technically be 1, 3, and then 2, 2, but we can't repeat the 2 within a segment according to the rules. So we actually can only be 5, 6 for that reason. Now, I'm noticing this cell here sees the entirety of our line. And so it's going to be whatever digit is omitted from the line. So it's not the sum, and it's not whatever digits make the sum in the 2 different ways. So if this was a 5, then this cell here would be the digit that's not involved, not 5 and not involved in a sum to 5. So not 1, 2, 3, 4. So it would have to be a 6. So if that's a 5, that would be a 6. If this was a 6, the digit that's omitted is the 3, because we'd be 1 plus 5 and 2 plus 4. But this can't be a 3 because there's a 3 in the row. So actually this has to be a 6 and this is a 5. All right. So that means these are from 1, 2, 3, 4. 3 can't go in any of these. Okay, so this sum here is a sum to 5, and the 3 is not involved, so it's a 1, 4. That makes this 2 plus 3, and then that makes this also a 1, 4. All right, this is not a 2 or a 1, 4, so this is a 5. That means all 5 of these are in the same region, and then we have a region border, and then we'll just call this the purple. Now, purple does have to get out, because it needs 6 cells. Now, this is only missing the 6, so it's going to have to grab a 6 from this column somewhere, and this is the only 6 it can get. So that finishes that region. In fact, I'm just going to do the whole border here. Now, this is the digit that's missing. This is the 2. And so these 2 are purple, and then we have a border. And then we need a new color for this. So this is orange. All right, this can't be a 3. So this is definitely not in the same region as the I'm not entirely convinced. I think regions can't wrap around each other, but I think maybe they kind of can in that case. All right, I'm not going to worry about it. All right, this is 1, 4, or 5. Well, it's not a 5 because then all these would be purple, and then this would also be purple, and this would also be purple. 4 might make sense. 4 might be okay. I'm not sure what else to do with that. Okay. So that was a lot of digits. This is not purple. I think it could be orange, though. Maybe we don't give orange a color yet. We know this is a new region, but a lot of these are new regions, it seems like. Maybe I need to think about the German whisper line now. There's nothing else to do. So there's 2 things that are always good to think about with German whisper lines. We don't know what's going to be useful yet, but I'm going to go over them. So the first is that it always alternates low, high, low, high, low, high. So if this low is 1, 2, 3, high is 4, 5, 6. So if this cell were a 1, 2, or 3, then the one next to it has to be at least 3 different, which means we're jumping into the 4, 5, 6 range. Then from 4, 5, 6, we need to be 3 different, so we jump back down to the 1, 2, 3 range. It's the only way that works. If I put 2 1, 2, 3s next to each other, how do I have a difference of 3? And the answer is the biggest I can do is 3 minus 1 is 2. So we don't know which way it alternates. It could go 4, 5, 6, 1, 2, 3, 4, 5, 6, 1, 2, 3, but it is going to alternate. So that's one thing, one property of it. The other property of the German whisper line is 3s and 4s are quite restricted. Like let's say we tried to put a 3 here. The only digit the 3 can pair up with is the 6, and so it would have to pair up with it in both of these cells, and that would violate Sudoku. So these can't be 3 or 4. These are from 1, 2, 5, 6. All right. Now I am noticing this cell is a digit that's not on this line at all. Now this line is 6 cells. So I guess that means this line has at least 1 repeat on it. So this digit is something that's missing from this green line. What do I do with that information? I'm not sure. I mean, I could fill out 1, 3, 4, 5 here to see if that's helpful. See, this could be a 3. No, this can't be a 3 because it can't be next to a 6 here. So this isn't a 3. This can't be a 3 because it can't be next to a 6. So this is from 1, 4, 5. So, okay, so we know that there is a 1 in one of these two. Remember that we alternate low, high? If we did 4, 5, they'd have a difference of 1. That wouldn't work. So we need to use the 1 with the 4, 5. Which means that this can't be 1. So this is a 4, meaning all of these are in the same region, and we're going to call that the orange region, and put a border here. Now purple has to continue, because it needs to get out somewhere. And there is a border here. And we're going to clear these 4s. So this is a 1, 5 pair now, making this the 3. So 3 is not present on this line, I guess is the conclusion. For what it's worth. This region needs a 2 and a 6. This can't be 2, 5, or 6. This is 1, 3, 4. Any little bit helps sometimes. These are from 1, 2, 3, 4. What can I do here? So I got this 4, I got this 3. We have 3 3s now. Okay. This is a new region. Because orange can't reach, purple can't reach, right? So we're going to call this the red region. And the reason I'm doing that is because this 3 we know isn't the red region. It's also not green. And purple can't reach now. There's no way purple's coming back around to here. So this is the yellow region. So I just have one more region. I have a blue region somewhere that I haven't accounted for. What does that tell me? Let's see. I have a 3 somewhere in here. I need a green 3, a purple 3, and a blue 3. 3 not being on this line doesn't tell us a whole lot. It just means that we don't put a 3 on it. There's no other like kind of restriction there. We need a 2 and a 6. So there's definitely a 2 or a 6 somewhere up here, because when we get out, we grab a 2, 6. But we could do this to grab the 2, 6. It doesn't have to both come from up here. Doesn't really help me, does it? Is there something about 2, 5, or 6 that I need to pay attention to? I'm a little stuck. Let's see. 1, 5. Okay, so if this was a 5, 5 can only go with 1 or 2. And if this was a 1, it can go with 4, 5, or 6. Not a 5, though. We're down to 1, 2, 4, 6. 4 would require both of these to be 1s. It's a little bit interesting, because if this was a 4, then I'd have to grab a 2, 6 from either here or here. And this would be a new region coming out. Could be purple region, though. It would be a 1, 3, or 1 or 4. Is there something about the fact that we need a 5 and we need a 6 in this column? It goes here or here. Purple could bend up. So if this was a 6, it would be forced to bend up. And then it couldn't go left. This would have to get out. I don't know what to do here. I must be missing something I can pencil. I'm going to pencil 1, 2, 3, 4 here just for the sake of it. Need a 6 over here somewhere. It feels like 5s and 6s are limited in some way, but I'm not sure how. Okay. Actually, this can't be a 4. Neither can this. The reason this can't be a 4 is we'd use 4 here, would put a 1 next to it, and this cell would break. So that's not a 4, and neither is this. It's also not a 3. So this is from 1, 2, 5, 6 as well. And so where's the 4 in the column? Only right here. And that's our 1, making that a 2, meaning these two are in the same region, but there's a border right there. I don't necessarily want to give it a color yet. This is 5, this is 1. So now this is high, so this has to be low. So that's a 1 or a 2. Now this is high, 5 or 6. 1, 2, 5, 6. All right, this is not a 1 anymore. 3 or 4. It's not a 2 anymore. All right, that was a good flurry of digits. How are we drawing these regions? Let's see. Is it better to think about these 2s rather than the 3s? They're in different regions. I don't really know what I'd do with that. I don't know what to say here. These could all be red. Then it could come down here for a 5, 6. This could be a region even. All right. I'm going to write 1, 2, 5, 6 here. Why not? This can't be 2 or 3, so 1. Oh, this can't be a 1, so it's 4, 5, 6. Is there... This is 3 or 4. So these 3 are in the same region. If it was a 3, it couldn't be with yellow. Or if this was a 3, it would be the blue 3. That's what's missing. So can we start a blue region like this? Is that an issue? If it was a 4, I guess, okay, if it was a 4, we can't turn right, and we can't turn, okay. So is this always the blue region? I'm going to argue that this always makes the blue region. So these 3 are always blue. So if this is a 3, then we know that's the final 3. So it has to be blue. So these 3 are blue. That's easy. If it was a 4, look what happens. All 4 of these are some region, which I'm going to mark blue right now. But imagine it. Where does this region grow to in order to get to yellow or red here to grab the 3 that it needs? Or sorry, can it grab this 3 or this 3, or does it use the blue 3 is the question, right? So it can't grab this red 3 because we can't get another 4 here. So we can't turn right here. Oh, and this would be blue as well. Anyway, my point is that we can't turn right and grab the 4. We can't turn left and grab this 2. And if we tried to come over here and grab this 3, we already have 5 digits, so we can only go left or right by 1 across here. So it can't be yellow and it can't be red for that reason. They're too far away. Okay, that's a much easier reason. So if this is a 4, because of this 2, we also grab this guy. We only get 1 more cell in blue. And so with 1 more cell, we can't make it to these 3, so we'd have to take the blue 3. So it is blue, is the conclusion. So these are all blue. This does not have to be a 4, though. Right. So what does that mean for me if these are blue? We know, okay, so we have a color for all of our regions now. We can't make any new regions. So what region is this in? It can't, red is the only one in range, right? It's not allowed to be blue because of the arrow. Orange certainly can't reach. And then yellow, how would yellow even get there? It's blocked off. So this is the red region. And what about this then? I'm not sure. These are just 3, 4, 6, just by Sudoku for the column. Okay, I have a color for all my regions now. Where does yellow get a 2 from might be the question, because it can't take this 2. And it can't escape out of this blob here. So this is the only 2 available. We don't have another 2 in this column. So this is actually the yellow 2, and then we have to connect them. All right. Is yellow the only one in range for this? Can we beeline here? Seems a little ridiculous, but it seems like it might on the surface possible. Just from 3, 4, 5, 6. Purple needs 2 more digits. It's interesting. This 1, 4 and this 1, 4 are in different regions, obviously. Well, no, I mean, we could do this, and then this could be red, and this could be purple or something. No, we know, okay, sorry. We know this one's not allowed to be purple because of the border. I had it orange at some point, anyway. Could blue beeline to it? Maybe. Otherwise, it's yellow in some way. I think it would have to be yellow like this. But if we did this, I don't know. It seems viable, to be honest. Am I missing some Sudoku that makes this more obvious? Is there something I can do with this? It's not the German whisper line, is it? I've been looking at it. I don't see how. 1 or 2 can go with 5 or 6. 5 or 6 can go with 1 or 2. So it doesn't really care how it resolves. 6 is in one of these two. Got everything penciled up. It was kind of if we assume the regions are unique, which is kind of a big assumption, but if we assume the regions are unique, then we can't have yellow take this 1-4 and blue take this 1-4 because that would be interchange. No, it wouldn't be interchangeable. Never mind. There's not really, no, there's not even an argument for that. Could purple take only these? No. Okay, so there's an argument that purple has to grow here because purple's not allowed to take this cell. So if it grew into here, which it very much can, it still can't grow left into here. So if we wanted to stay to the left of this barrier here, we'd have to take this one. And now the issue is that these two need to be in a region and purple is done. So they have to be in yellow. And now yellow has 1, 2, 3, 4, 5. It has to grow, but it has nowhere. It can't grab another one because it already has the one over here. So that's kind of along my point of how these are somewhat distinct. And so purple has to take this cell at least, which means it's not a 6, which means the 6 is placed here, which means these are not 6s. Okay. So now purple just needs a 1. There's a barrier here. Purple can't get a 1 by going up, so purple has to get a 1 by going here. All right, now purple's done. And this is a 1. All right, that's not a 1. Now orange has to grab this 6, and then it has to grab this, and it has to be a 2. This 1 made that a 2. All right. And now orange is done. Okay, perfect. Pretty intricate here. This 2 needs to join a region, and its choices are blue or red, but blue already has a 2. So it's got to be red. We can draw those borders. So red has a 1, so this definitely isn't taken by red. Blue needs a 1. See, these aren't 2s. Places this 2. 3, 4 pair places a 6 here. That's not a 6. That makes this a 5. 1 and 5 here. That's a 6 now. So that's not a 5. Here we get the 4. Here we get the 6. Just realized I've been at this puzzle for almost 20 minutes. But we're making progress. So blue can't take this 6, so it has to be red. And now red takes the 4. Perfect. Now blue could take the 1 over here. We still don't know if this is 3 or 4. I think it's going to get resolved by whether the 1 is blue or not. Blue or yellow. Let's see. Maybe Sudoku will do it. We'll see. Were there any... I don't think there were any more arrows that would have helped me out here. So what are we doing here? 3, 1, 3, 4. Okay, so this has to be a 5. So blue can't take this. So the only option is for yellow to take it. There's only blue and yellow left. So we're going to have to get to this somehow. Well, yellow has 2, 3, 5, 6. It needs 1 and 4. Oh. Okay, so let's think about this case. If yellow took these two, getting its 1 and 4, then blue would take these two, meaning this would be a 4. That seems to work. If yellow took this one, it would take this one, making this a 4. Ah, that doesn't work. Okay, so look what happens. If yellow takes this guy, then this has to be a 3, making this 1 and 4, and now yellow can't connect down and take a 4. Oh, wait, can it? No, because we can't isolate these guys. So just about not isolating this 4 here, for this cell. Hold on. I mean, I think I just proved it, but I'm wondering if there was an easier argument here. Wait, what am I doing? I don't know. Sorry, I don't want I don't want that yellow. Okay, sorry. What region is this guy in? It's certainly not in blue. I can't reach it. So this is in yellow as well. And so now to connect these up, we either connect here or here, but if we connect here, this gets isolated. It can't be in blue. So that it has to be here. And then blue takes these two, which was the solution anyway. All right. That was just much easier to prove. All right. And so now this has to be a 4 because it sees 4. And that resolves all of these things. All right. It just says G. Is that intentional? I don't know. All right. Well, cool puzzle, ChinStrap. Really difficult. Really difficult. I don't know if there was like something I missed that I don't remember like what kind of the key deductions were because I just kind of had to pedal through it. But yeah, it was an interesting one for sure. Definitely on the difficult side. Let me know how you did. And if you enjoyed this, why not leave a like, subscribe, and a kind comment below.